Guys, welcome back to another episode of the BlockHash Podcast, episode 394. Today, I have the CEO, Nick Dodson, here to talk about Fuel Labs and the FuelVM and how it contrasts against other rollups within the ecosystem as well, and really what makes them powerful, unique, special, and different from what else is out there. So, Nick, welcome to the show, man. Excited to talk to you today and learn a bit more about what you guys are building and putting together. How you doing?
Doing really well. Yeah, thanks for having me.
Pleasure's all mine. Before we dive in and start really kind of learning more about Fuel, tell me a bit about yourself. I'm sure people will want some context and background as to maybe who you are and what you've kind of done in the past leading up to Fuel.
Sure. Yeah. So my background is kind of all over the place, quite frankly. There's a lot of different random things in there to cover. I'll try to be as concise as I can. So I started in the space at around 2013, initially working off the Bitcoin stuff and working off altcoins actually like during that time. Before that, and even during that, I was also a musician. So for me, playing drums is part of my life. My whole family's musicians actually. So that's like
oh, cool.
A small side note. But yeah, I was always doing coding since I was young. So for me, always doing stuff, trying to build video games. That was initially where I started. And then, that grew into trying to actually build certain things on the web. So, for what it's worth, a lot of the PHP and LAMP stack was really effective at building certain things, quite frankly, even still to this day. So, humble beginnings starting there, and then moved into actually working with servers, and then starting to work with crypto. And when I was doing that, did a lot of mining, and I was doing a lot of mining out of my house in Canada. So we were heating our house with GPU heat for quite a while, and then
best kind.
Yeah, exactly. Very, very expensive power, but still, an interesting way to exist. And then, after that, I started to want to build more on Bitcoin instead of just mine things and do that sort of thing. So, found Ethereum, and basically after that, the whole life shifted. And with Ethereum, initially was starting to build some of the very first apps on Ethereum. So I remember like when the Ethereum website went live, there was 10 apps on the website, and I had two apps out of the 10 on the website. So I knew I was covering a lot of ground at the time.
There you go.
Initially like crowdfunding and then some governance stuff. So that was like, early 2015, 2016, that area. I joined Consensus, and I worked with Consensus for several years, doing a bunch of different things. So building out apps, but also writing some infrastructure, some of which was used almost up until right now, even in things like MetaMask and stuff like that. So some of the lower level libraries in the JavaScript ecosystem. And then after that, I left Consensus and wanted to basically seek out. Initially, I just wanted to build a wallet, actually, quite frankly, and so it started with that. But down that trajectory and that rabbit hole, you start to realize that your options for building a wallet that can do cheap, secure transfers on something like Ethereum is highly limited, especially when you have lots of users use Ethereum at once. Then the gas price just goes crazy. So your app becomes dead, basically. So that led me down the path of trying to find some other solution other than what was available, which was effectively at the time just Plasma. There was a few conversations around ZK, and then there was state channels and some really basic stuff. So you eventually found optimistic rollups, found the technique very useful for basically packing a bunch of transactions onto Ethereum and trying to do that in a safe way. And so largely the project then sort of shifted from just doing a wallet to focusing really on the actual infrastructure itself and saying, hey, like, we could actually do this in a much more comprehensive way. And so with Fuel, we we started by just doing the optimistic rollup itself and doing transfers and swaps. Most of the volume on Ethereum at that time was just transfers. So, you could do a solution around that, and that made sense. This was like around 2019. And DeFi was just starting, like DeFi summer was just happening. So we sort of came out of it, I think, just during or right after DeFi summer. So Uniswap became kind of a thing towards when we finished the first version of Fuel, which was in December 2020. So we launched the first optimistic rollup to Ethereum mainnet, and that's like still the only optimistic rollup that actually met all the security criteria of a rollup. So we wanted to really inherit the security of Ethereum while also processing a lot of transactions and a lot of throughput, and have all the fraud proofs, remove the multi-sig, like have a special upgrade process, do an advanced sequencer and a slow forced transaction inclusion. So a lot of the stuff we conceive of in rollups today comes from FuelV1, basically, because that was sort of the model at the time. So I built out all of FuelV1, initially wrote that in Yule, which is the intermediate language to Solidity, because I really was super tired of Solidity at that point. So Yule was a nicer choice. And then basically after FuelV1, we wanted to just go right into what we thought was going to be like most valuable for the community, which was challenging not just the fact that Ethereum's pretty EVM oriented, but basically that if we really want to scale Ethereum to the entire world and we want to get it out there to everybody, we want everyone to be able to access it. Unfortunately, we're going to have to fundamentally change some of the ways that our system works and leave behind things like the EVM, leave behind these other concepts, and try to bring in new concepts that can bring in a lot more performance for Ethereum itself. So when we did Fuel V1, we didn't do an EVM or account-based model. We did a UTXO model. And we did that because we could retain light clients, we could do fraud proving, we could do parallel processing over all the transactions. And we could also basically have a much cleaner model that is lighter on state. Once something is spent, it can be removed from state. So if you manage that correctly, you end up with a much more state efficient system. Sometimes people argue the opposite, but we can show that that's actually not the case. And so when we were doing Fuel, this new virtual machine architecture after Fuel V1, we wanted to make sure that we built a virtual machine and an architecture that not only used this UTXO model, but expanded upon it, brought in Ethereum style smart contracts, brought in a lot of nice primitives from Bitcoin, like pay to script hashes, retained that parallelism that we wanted and that scale, but gave us something that, we felt like the entire world could actually use, and we wouldn't hit the same kinds of bottlenecks that you typically see with the EVM right now, with the accounts model and the way that Ethereum is designed. And the key thing is, like, it's sort of easy, just to talk about contrasting, it's easy to just throw away cryptographic proofing. And then you're Solana, just like throw it all away. You just, do whatever you want in the database, and a full sync is required to verify everything. You could do that, but we didn't want to do that. We wanted to retain what we believe is really important to crypto, which is light clients, but still fix a lot of these other core issues, and also retain things like the way that Ethereum smart contracts work. They work really well. Like, they're very effective at allowing devs to build these really interesting primitives that we see today. So we wanted to retain that also. But basically, Fuel is sort of a very weird mix of everything you see in the space in some fashion or form. Whether it was done because we looked at these models or it was just done because it was a good idea, we basically tried to bring as many good ideas into the architecture as possible. And that's sort of where we're at now, is we're getting closer to testnet with Fuel V2. And it's bringing, again, a whole other virtual machine, a whole other way to process transactions. But we also have our own language, and we have our own tool chain. We have our own infrastructure. We have our own way to do everything, mainly predicated on the fact that we've spent so long building off of Ethereum that we sort of know what we want, and we know what we want to see from the system. And we're not afraid to try something different. And we're not afraid to do something a different way just because, everyone tells you not to do it. And that's why we did it. So we're trying to force factor a different kind of architecture into Ethereum, because I think it's really important. If we just stick with the existing paradigms, we'll never have explored all these other potential avenues that are in the design space. So hopefully that gives you a little bit of context about me and also the project, but it does kind of wind into each other a little bit.
No, that's awesome. I definitely want to touch on some of those points that you just mentioned there. To add a little further context, why do you think, or what is the reason for why networks like Ethereum need these architectural rollups like FuelVM? Like what's the problem with blockchain today?
Yeah, I mean, there's a few things. I think so. Ethereum is sort of transitioning itself away from doing everything. Like it used to do. It used to be. We used to call it the world computer. Like these kinds of things.
Hmm.
And once we actually started to use it for anything, we realized, it's a pretty bad world computer. It's like not really that
Yep.
great. And so Ethereum kind of quickly rebranded itself. Now, fortunately, Ethereum was sort of first, so it could make a few mistakes. It didn't need to have the world's best positioning or whatever. And we weren't people weren't building for Ethereum because of just the tech. It was also the leadership that Vitalik showed, his ability to communicate ideas, communicate his assessment of things, and for us to build a more cohesive, value-oriented community around blockchains themselves. So Ethereum's like a lot bigger than just the tech, but the tech's really important. The tech's like the byproduct, right? And so, Ethereum, when it initially started, was pretty bad at everything, quite frankly, and it really couldn't scale very well. And Ethereum's now, after it's sort of secured itself, moving to proof of stake, it's now in the next transition, which is moving to rollups and moving to trying to be a data layer for all these different new kinds of execution that we'll see in the space. And so it's opening a new door for rollups to have this kind of globally secured, amazing peer-to-peer blockchain, but with all kinds of different options for us to build infrastructure-wise. And so Ethereum's really just becoming a great witnesser of these different blockchains. And in doing so, the Ethereum layer itself can remain sort of simple. It's basically just, millions of people witnessing a bunch of data going over the wire, signing off on it and moving on to the next thing, and then eventually just throwing it away and not having to store it. And that keeps that core system that Ethereum offers really straightforward. And then off of that, we can build sophisticated, interesting kinds of blockchains on top. And this is where rollups and layer twos come in. And so effectively, I think what we see in the space is a lot of people building EVM rollups again on top of Ethereum, which is a natural thing to do. It totally makes sense. It's a great business decision. You can copy and paste your apps on Ethereum, and now they're in this layer two, or they're in this rollup, and that was the natural inclination of a lot of teams. The issue with doing that is you've now just inherited all the problems that got us here in the first place, and you've just put them in another place. you've just brought them up one layer. And yes, it's cheaper because the processing is now more localized to a central builder, and things are getting better with the EVM. They're making a lot of different strategic improvements with RETH and other things. So you could say that the EVM is going to get a little faster that way, but it's not really solving the problem. The whole reason why we're here is because the EVM wasn't good enough in the first place, right? If it was, we wouldn't need to even do rollups at all. We could just use that, and we would never even have to think about doing all this other stuff. So when we built Fuel V1, the reason why we didn't choose to do the EVM again is because we know from first principles, well, this machine sort of put us in this position in the first place. Let's not recreate the same problem. And then secondarily, when you take these other architectures that weren't really designed for blockchains, like WASM or RISC-V or all the stuff you see in the space, they're very great to build regular software out of, right? And run, some of them are CPU architectures, so they're designed to run like a CPU. Some of them are designed to run software in a browser, but they're not really built for blockchain. And when a VM is actually built for blockchain, it probably comes with a bunch of additional things, right? It comes with things like systems in place for assets, right? And a standard system for how you just use assets, right? It would come with things like special cryptographic instructions. It would come with a way to interpret different scenarios that you only see with blockchain computing, that you don't see with like regular computing in general, So those infrastructures are great for writing an email client in a video game. Blockchains are, as we can see, very different kinds of machines, right? They have to be globally witnessed. A lot of different people have to verify them. And even with ZK and sort of the advent of ZK, you still want a very fast blockchain because you need to first process it in order to build the ZK. So yes, you could run anything through a ZK, but it actually matters a lot about what you're running, because even then you still need to take that, whatever you verified, and then you need to ZK prove it. So basically, all the same principles still sort of remain. So blockchains have unique challenges that other environments just don't have in computing. And so it really does call for its own kind of machine, its own kind of system to deal with these challenges. And you can always build a blockchain with whatever you want. You don't have to do this sort of stuff. But I think what Fuel will show is that it's way better to have a VM that's optimized for blockchain computing. And if you want it to be really good, then you also want it to run everywhere in different ways, different levels of scale, and be very flexible into how it actually works. So these are all things that we want to achieve with Fuel.
Well, it sounds like you guys are very ambitious. You guys have a lot of things that you guys are working on at the same time here to make this, very successful. But what would you say, like, if you could highlight a couple things, what makes you guys superior as an Ethereum rollup compared to the other competition out there? Like, how do you guys flex on the competition in terms of the way that you scale?
Yeah, so I think a few ways, and it actually has very little to do with our tech. Our tech's very good, and we can flex on tech all day. But tech is just software, right? And everyone can write software, so you can't really use software necessarily as your position. I think what gives us the biggest advantage is the fact that we didn't follow any other project. So we didn't follow Move, we didn't follow Solana, we didn't say like, hey, we want to take those ecosystems and we want to put them on Ethereum. We didn't do that. What we said is we have a problem. We're Ethereum builders. We're Ethereum people. We have a problem on Ethereum. How do we solve our problems for rollups and for what we experience and like what we've experienced in the past? And like, how do we actually approach all these problems more from first principles and say, let's build an architecture that is unique to what Ethereum is, but also to the challenges of rollups, to the challenges of the day, and give us all these different properties that we're looking for, and doesn't follow anyone else. It's really its own unique thing. And when you do that, it opens up a door that very few people have, which is if we think there's good ideas out there, we can incorporate them very quickly into the FuelVM. So we built an architecture that's extremely flexible. Our VM is multi-context, so you have many different kinds of processing context inside of it. We have predicates, which are like account abstraction. We have scripts. We have contracts. We have as well like different settings for other things. And basically, if there's different ways that blockchains can operate or run, we're in a great position to be flexible, add those things into our system and have a better platform to build off of. So I'd say that one of the biggest advantages we have is we just didn't do what everyone else did. And that's obviously harder when you start, but it's a lot better later because anything that you see in the space that's good, we can incorporate. If it's actually good and it actually helps a dev or it actually progresses things forward, we can crush that. And very few projects are even in that position to do it. If something great comes along, a new way to do smart contracts, try doing it through the EVM. It's a nightmare. And then try scaling it. Right? Whereas for us, because we've picked models, both our flexible transaction model and our flexible virtual machine model, and the fact that our language supports all these different contexts, we're in a position that very few projects are in because we both are designed for blockchain and very flexible. But we also are very adaptable. So essentially, I think in the end, that will serve us really, really well. But that's because we basically didn't do what everyone else did. So we just did something different. Yeah.
I also know that you guys have your own programming language too for FuelVM called Sway. Can you talk a little bit about that as well?
Yeah, for sure. So I think the main thing to mention there is that you can always, so I think with programming languages in general, there's a few points to make. One is Solidity, while it has a ton of problems, it actually did the job for Ethereum very well, I would argue, in terms of trying to basically tool the Ethereum virtual machine. So in a sense, like Solidity really achieved a lot of its goals by being a language for the moment. And Solidity has been extremely valuable for Ethereum just as a system. That being said, I think that with the advent of all these new languages that came out for smart contract programming, and also for just programming in general, like Rust and Zig, for example, there's just really great new languages to pull ideas from that have completely changed the landscape of computer science and programming, quite frankly. And we wanted to bring in a lot of these new ideas into a really flexible language that was designed for blockchains and not just repackaging those languages. So you can take Rust in theory, or C or Go, and probably target the FuelVM. You could, but there's a reason why we don't do that. And the main reason is because if you've ever seen a language try it, it looks and feels horrible. Like basically, it's like a giant clusterfuck. You have to band-aid everything, annotate everything, restrict everything, because those languages are built to target your CPU and a computer. They're not designed to target a blockchain. They're not designed with the concepts of a blockchain in mind. Mm-hmm. And so having a language that is designed for blockchain is really, really important, because it brings in all the nice concepts that we've learned from things like Solidity and these other languages, and tries to give you the best developer experience you can for that virtual machine. So Sway's whole idea is that we like some things from Solidity as a language. It's a blockchain specific language, but we like a lot of things from Rust. And we want to bring these different properties together into something that's special, that can target our system, give a developer a really great experience, but also be a multi-context language that can work for all the different contexts that FuelVM works in. And as well, all these additional contexts that blockchain languages don't typically do, but that they should be doing, like testing or deployment or indexing. So when a developer learns Sway, it's actually going to allow them to tool their entire app and build that in a standard linguistic way that very few teams will be able to do. So having your own language is like another crazy superpower, basically. Whereas like if you don't have it, then you're always at the mercy of Rust, you're at the mercy of C, you're at the mercy of these other languages, and you're at the mercy of the LLVM toolchain, which you have to keep up to date, which is a giant pain in the ass. So basically, trying to avoid that at all costs, I think, is going to be very beneficial. And I even think Sway, in the end, will also target all these other blockchains. So we'll create backend targets for MineVM, for Noir, for Stylus, Wasm, for all kinds of different settings, because it's actually a perfect way to attack some of those things. And eventually the EVM as well, once the language is mature enough. And this also includes things like runtime proving and other things like that. So its flexibility will actually be the reason why I think it'll be the next language for blockchain, and not necessarily because of any other one property. And even you'll see with Move, most of Move's security properties are not conferred from the language itself. It's conferred from the virtual machine. And that's a decision that the developer has to pick. And that's very different. So for us, it's all about flexibility. And as well, the language confers a lot of safety on top of that.
Is it similar to Solidity in some ways, or is Sway like completely different and completely retooled?
Yeah, so I can actually show you if you want to see.
Sure.
So let's just go present. Share screen. Sway Playground. So this is like our in-browser editor here, Sway-Playground. So this is like a counter contract example, if you can see. So what's really cool about Sway is that you are defining the context here. So here you can see it's a contract, but you're bringing in some nice things. So these are properties that we brought in from Solidity itself. So here I'm defining an ABI, right? I'm defining how it touches storage. And then I'm defining the storage layout too. And both of these things are exportable and configurable, right? And then I'm implementing a trait for the exported contract. And here you're seeing again, just it's sort of like Solidity, but if Solidity was properly tailored, right? Like for writing smart contracts was maybe a little safer, was maybe a little more flexible, had a better, maybe more flexible trait-oriented style type system. And if you want to compare and contrast, you can also do something like this. So we also have a full Solidity transpiler. So here's our counterexample in Solidity, and here is it transpiled over to Sway. So you can inherit, because Solidity and Sway actually share so much together, you can actually transpile a lot of Solidity over to Sway, which is helpful for learning, right? So like here's an ERC20
Yeah.
token. Now, mind you, the ERC20 token you see on the right, it's at the application level. Fuel has a lot of native asset features that this transpiler will pick up on as like an additional feature, and will actually say like, hey, this is a token for Ethereum at the application level. Let's transpile that down to what a native asset looks like in Fuel, which for us is a little different, like you can see here. We actually, with native assets, you have your standards here, but you actually mint the asset and it kind of comes out of the contract, and you can actually transfer it around outside of the contract. So full UTXO kind of model. So when you mint, you actually mint the asset, and that is taken out of the contract state. So it's like decoupled. So there's some really cool benefits of that. But basically, the transpiler will allow you to move between Solidity and Sway quite easily, but also we'll try to make the transpiler even smarter. So it'll pick up like, hey, I see this as a token. Like you probably want to do that in the native asset way in Fuel. This is what that would look like. And then that way it's like, that's as good as we can get a transpiler. And then you should probably not trust the transpiler. You should probably write it yourself, but at least you can learn really fast coming from Solidity, like what Sway is and how it works. Yeah.
Yeah, it's going to be really helpful for developers too that have put the hours in to learn Solidity, and then they find out that they got to use Sway and they're trying to learn it. This kind of probably helps them translate things a little bit and kind of get the gist of how it works and cut down maybe on the learning time.
I think so. Yeah. It's like trying to make that Solidity to Sway burden as low as possible is great. But I also feel like devs will really appreciate this stuff when they can write everything in Sway, like one language. You do all your indexing, deployment, testing, every kind of like structure that you want across the entire board of your app is all like done for you properly. I think it'll save devs so much time that, similar to like Flutter, where you can write, many different apps for many different, targets, same kind of thing. I think it'll save devs a lot of time, but for blockchain specifically. Yeah.
Very nice. In terms of, Dapps on field, like, are you seeing Dapps being built already? And if so, what kind of things are you seeing being developed in terms of use cases?
Yeah. So right now, like on the higher end, if I were to say, we have about like 50 projects building. There's maybe 5 or 6 that I think are worth showing and just checking out. And obviously, we're improving everything like from the infra, like front to back. So there's still a lot of improvements to go. But in terms of apps, like we're definitely seeing with the UTXO model, UTXOs can turn themselves into orders, basically in an order book. So we're in an excellent position to build these very performant, low-level order books, and the orders can be congruent to every other order book. So if you have orders on one order book, they can actually be brought into a separate order book because they're all part of the same class of just UTXOs. So if you open up one order book on Fuel, some other order book can just add those orders in. Like basically you can share the space more effectively for things like order books. So these UTXO, like native asset-based order books, are definitely something we're seeing a lot of. And we're, you're trying to make sure that they get the best chance they can as well. So it's like Sail and Poolshark. Actually, Poolshark will do AMM style. So it's Sail and Spark will be the ones that are targeting order books first. And then we have some AMM designs, that do kind of Uniswap V3 style stuff, like Poolsharks. And basically, we're just trying to make sure that when we go live, we have enough of the basic primitives, you could say, like AMMs, order books, lending, NFTs. On the NFT side, we have a really great project called Thunder. And then on the wallet side, we have a great native wallet called Fuelet. So the core ecosystem is maybe 5 or 6 apps right now, but it is growing. And we have a lot more people that are, quite frankly, pretty disenchanted with the existing landscape of EVM clone chains and don't care anymore and would just like to use something different. And I would say that for every primitive you see in the space, the way that we want to evolve our ecosystem is to basically bring people closer to building more stateless apps. So if you want to make your app truly scalable to the entire world, reducing the amount of state it uses and trying to use that more carefully to avoid contention in a global setting is like really, really important. So trying to design your app and your smart contracts around statelessness will be like really imperative. And in that, we want to push people more towards what we call like the fuel way of building things. So you have kind of the EVM way, everything's a smart contract, everything's in a giant Merkle tree. Like this is going to be, pretty awful to process, pretty contentious. Like some person in India could hold up someone in the US trying to make the same trade. It's like, you don't really want that. Instead, you want to, break away that contention, reduce that state, and kind of move towards a more state minimized design. And in that, we're trying to push the apps forward into a different setting. So it's like, could you be more clever? Could you graffiti state onto assets and then bring those into our transactions and use them and rehydrate them over bandwidth, for example? Like use other areas of physics that we have in the processing so that you're not using just smart contracts. It's like you can always do smart contracts the Ethereum style way if you want. And yes, we'll have those. But there's an even crazier way to build an app, and that's to do these more wilder designs because they're going to be way cheaper, way easier to process, way less globally contentious, and you'll really be designing then for the entire planet and not just like for a 5 to 15 TPS like EVM rollup. Like you don't want to design for that because it's too small thinking. You want to go a lot bigger. So that's where we're pushing everyone. So with each of these designs, like whether it's AMMs, whether it's multi-sigs, whether it's other things, we've got sort of the standard Ethereum way you can build it, and we will tell people how to do that. But then we've got the crazy fuel way to build it, and it's like try to go way further. Like try to mint an NFT, graffiti some state on it, and then rehydrate it over bandwidth, and and then maybe even have the builders do that. And it's like that's like a much crazier way to build smart contracts. Yeah.
Nice. Do you guys have developer resources or docs on your guys' website or in a repository somewhere where people can kind of, if there are developers existing that want to kind of get into FuelVM and start building things and, learning Sway, where would you send them?
So the best two places are just docs.fuel.network and forum.fuel.network. So both of those places, we try to have a really fast response time on the forum. And then as well, and that's where I would just ask or look up any sort of questions. And then we're just trying to build that up. And then the docs right now, I'll admit, we've got docs that cover everything in theory, but the docs still they have a long way to go, I think, in order to be really fulfilling. So we're still putting up like a whole fuel book, basically, that describes the entire project, in detail. Also for researchers, for different people, right? And then we're in the process of redoing some of our core books. So we just redid the TypeScript book. We're gonna probably take a big look at the Sway book, but you'll be able to pick up the language that way. If you just want to fool around off a browser and don't want to install anything, just sway-playground.org is great. And I would just say that, maybe in about a month, I think our docs will be very, very solid so that, devs can feel really at home reading those docs and they have a good experience. Right now, you're going to be eating like a little bit of glass. There's still some infrastructure and other things to figure out. But you can get a sense of where we're going, I think, as a project. Yeah.
Couple of higher level questions here, and then we'll slowly start wrapping up the episode. The first one being, in terms of scalability challenges, what are some things that you think rollups just generally might struggle with that's not common knowledge that most people don't know about?
In terms of what rollups will struggle with a lot is, I think building a safe fraud proving system is going to be really challenging. So for us, we're like more ZK pragmatist, I guess you could say. So we like using ZK wherever we can fit it in and use it. So for us, like our proving for an optimistic rollup is just ZK. So whenever there's something invalid, we throw that through a ZK prover, and then we can prove that it's true or false. This is a lot easier to do given Fuel's block design and our transaction model and the way that things work. I would not want to do this in a very highly contentious state system where you have like a lot of unknowns, a lot of different things. So basically, that would be one of them. I think fraud proving is really difficult. I think moving beyond the EVM is going to be very difficult. If you've established yourself as an EVM rollup, you have only one option, which is to progress the EVM rollup. And that really sucks. I think Arbitrum's trying to bail themselves out right now by having things like Stylus. which is good. But at the same time, that's going to be really painful to move any devs into that, right? Because they've sold themselves as an EVM system, and they always will be. So it's going to be very difficult to leave that. So I think that's another one. And I think the last one is just that state is always going to be a problem. So trying to reduce it at every level is going to be really key. And if you haven't designed for it at the very beginning of your system, you're kind of screwed, because you're always left with a system that just has to always use more state in order to fix things. And you see this with like the way that account abstraction is being designed on Ethereum. It's like, it's even worse to use than a lot of other things. And it's just going to continue to get worse and worse. And like, you know, for every smart contract in the way that they're currently designing it, it's like you have to hold this giant Merkle tree. It's like, this is a lot of data. If you think everyone's going to use a wallet, like a multi-sig on planet Earth, then you're not planning for the right things, you know? So basically changing the fundamental designs will unfortunately be what everyone will have to do. So I always say with all these designs, unfortunately for all these other teams, all roads lead to Fuel. Yeah.
What do you think blockchain will look like, and how do you think it'll evolve over the next 5 years or so? And then what role do you think FuelVM will play in that change, in that evolution?
Yeah, I think blockchains will change from being center stage things to being far more back end and far less interesting. I think things will harmonize pretty quickly. Still a lot of experimentation to do, but I think that things will unify over time. I think there'll only be a few predominant architectures left that can make it through the mud of trying to be an architecture worth building all your stuff on. And you have to cross a lot of different barriers for that, both all the different tooling and infrastructure and all the different considerations that a blockchain has. So I think that in the future, there's very few architectures to run everything on that actually meet all the different criteria that you'd really be looking for. I think Fuel is one of those architectures, and I feel like there may be one or two others. And I would just say that I think blockchains are going to change significantly to sort of unverified browser-based apps that you see right now to being much more verified, hardened systems that every action, every move, every single event that happens over the system is far more real time, and it's far more verified, basically. And I think that that's the place that we all wanted to get to if we really want to build a system that is extraordinary outside of a single country or government, basically.
Do you think that there will be one rollup to rule them all? Or do you think that there will be many rollups that can fulfill different roles and different niches and different use cases?
Yeah, so I think there'll be a few settlement rollups on Ethereum. And then I think there'll be millions of what are effectively application level rollups built off of those systems. So I think the right model is like layer 2s and layer 3s. And in a sense, I think there's going to be millions of layer 3s like there is millions of applications. And the reason why is because it's sort of like, why not, copy and paste some of that architecture that's working for you, but then tweak it so that it can just do exactly what you want it to do. And then that way, like, you really crossed all the different boundaries and all the different flavors of things that you want. So for me, I think something like that will be the right balance, and there'll be millions of rollups. It's just there'll be rollups in the layer 3 fashion and probably only a few layer 2s that are really effectively writing to Ethereum. Yeah.
Nick, this is the end of the episode. We've talked about quite a few things. What do you want to leave people with? Any final thoughts, calls to action, regards, FuelVM, where you want to direct people?
Yeah, I would say just check out all the stuff we're doing in the docs, in docs.fuel.network, the forum.fuel.network, and as well, follow us our Twitter, fuel_network, and basically, we'll need all the help we can get to basically bring this kind of architecture to light. If you feel like this architecture actually speaks to you as an engineer or you as a person building something, I think for us, we want you to come build with us. It will be a bit of eating glass, but it'll be a lot of fun because it's a completely new system that we can really design for people's needs. And as well, I would just say that, end of the day, you're probably going to get bored building off of all this other stuff, and you'll have no differentiation. And for us, we want to push every project that builds with us to build new kinds of apps that you've never seen in DeFi. So effectively new kinds of DeFi. And I think for us, like, we have the tech and the ideas and the abilities to push that forward. And we have the reason for you to do that, right? A different kind of VM and a different kind of system. So I would just say, just reach out to us. Like, we're here to help. Reach out to us on the forum too, or on Twitter. Like happy to talk. And I think for us, like, we know how hard it is to grow these things. We've been through a lot of blockchain in our lives. So, we've got an uphill battle ahead, but we're very excited to welcome in new projects that actually hold our beliefs and our values and want to push Ethereum forward in this way.
Are you guys doing anything interactive or educational at the moment, like workshops or webinars, or maybe attending conferences where maybe people can kind of, dive in a little bit deeper, maybe interact with you guys and learn hands-on?
Yeah, for sure. So we're going to be doing a bunch of events where you can come hang out, work with us, see our stuff. We'll show you code. We'll show you everything, like DappCon, ETH Berlin, that whole thing. ETHCC will also be at DevCon. We'll be everywhere at the major Ethereum events for sure. And we'll do a bunch of virtual online events as well, and some online hackathons over the next 2 quarters as well. Just let us know about everything, grants, otherwise, like, happy to support where it's reasonable. And I would just say, just keep an eye out. We'll be running a lot of that stuff, both online and physically. Yeah.
Cool. And if anyone wants to get in touch with you, are you on LinkedIn or socials anywhere people can maybe connect, collaborate, share ideas?
Yeah, just message me on Twitter. I don't.
Okay.
I have some kind of LinkedIn profile, and all it's produced is an enormous amount of cold calling over email. I hate every second of it. So yeah.
Thanks for taking the time to come on the show today. It was a pleasure to have you on and to learn more about what you guys are building with Fuel. I think it's really good. I love the competition in the space and everyone pushing for the best kind of roll-ups and the best ways to scale up. Ethereum in particular, I have a soft spot for Ethereum because that was my first entry point into the space. So I like seeing people continuing to innovate on it and make it better and create opportunities. So kudos to you guys. Keep an eye on you, and let's do another episode here soon in the future.
Absolutely. Yeah, likewise. And we like Ethereum too. So, hence the level of effort. Yeah. All right. Awesome. Thanks for having us. Thanks for having me.